So good afternoon. We will continue the remaining part of network primer 1. So yesterday we have covered the overview of computer network, different component used in computer network, then communication channel, different types of communication channel, examples of node, then benefit of network, then client server model, different types of server, different addresses, various addresses used in cyber world and different ecosystem. Then role of administrator, then internet, intranet, network segmentation, benefit of network segmentation, and technique, general technique used for network segmentation with respect to cyber security. Then LAN traffic congestion, collision domain, broadcast domain, and we have also compared the security with respect to broadcast domain. Then with respect to devices like hub, bridge, switches and router, we have covered collision domain and broadcast domain. And these are the lists of broadcast based protocol. So these protocols basically work on the principle of broadcast messaging. Then transmission mode is there, Ethernet. So now coming to cabling type. So basically LAN use either copper or fiber optic cable, and this copper cable can include the UTP cable, STP cables, and the fiber optic cables generally use light emitting LED or laser light to transmit the data in the form of light wave. And these are the different categories of UTP cables category, starting from Cat 1 to Cat 7, Cat 8. This is the diagram of UTP cable in which two RJ45 connectors are there at both ends. So there are 4 pairs of wires. Why these wire pairs are there? Why it is twisted? To nullify, to cancel the electromagnetic interference from the external sources. So by twisting this cable, the external electromagnetic interference will be nullified with the help of electromagnetic field principle. And with respect to fiber optic cable, we transmit the data in the form of light wave on the basis of total internal reflection. So this total internal reflection is the main reason how optical fiber works. So as a light source, there are two options. If we have a switch or router having fiber module, so this fiber module can work on the basis of LED light source or laser light source. So it depends on particular fiber module present available in the switch or router device or any networking device which is having support for optical fiber cable. So these are the different connector, SC connector, ST connector, LC connector, and there are two types of optical fiber, single mode fiber and multi-mode fiber. So when we see the diagram, in the single mode fiber, we generally transmit a single wavelength of light wave. So it is sending only one wavelength of light for data transmission. In the multi-mode fiber, different wavelength of light can be simultaneously transmitted. It is showing that 3 different rays light waves are transmitted having different wavelength. So this is the property of multi-mode fiber. So there are some benefit, demerit, merit of single mode and multi-mode fiber. So single mode fiber have a small core, it is costly, and generally single mode fiber use laser light to transmit data in the form of light wave. High performance is there. In multi-mode, core is large. It is comparatively economical, and it can use laser or LED light. Low performance. So this is the difference between multi-mode and single mode fiber. So generally in the campus where we need to connect two network device or two PC connected with the help of optical fiber, if distance is less than 500, 600 meters, then we can use multi-mode fiber. But for more distance, generally single mode fibers are preferred. So depending on the optical fiber category and standard, this length can vary from 0 to 100 kilometer for single mode fiber, and for multi-mode fiber up to 2000 meter, means 2 kilometer. Up to 2 kilometer, the multi-mode fiber can be used. Coming to Ethernet cabling. So there are three types of UTP or Ethernet cablings are used in local area network. So whenever we want to connect our desktop PC or laptop PC with the switch device or hub device, or sometimes we need to connect with router. So there are three types of cable are available in the networking industry or networking scenario: straight through cable, crossover cable, and rolled over cable. So mainly we are learning this just for networking overview. As a team leader, as a group leader, uh, we should be familiar with the different types of cable used by network engineers or vendors. So this is straight through cable, crossover cable, and rolled over cable. So basically straight through cables are used when we are connecting two different devices. So normally it is a general practice that two different devices are connected with the help of straight through cable, which is made with the help of UTP cable. Only wire, the pairing of wire pairing and order of different pins are different with respect to straight through cable, crossover cable and rolled over cable. तो कौन सा केबल है ये डिपेंड करेगा कि आपने पेयरिंग कैसी रखी है, पिन नंबर में 1 नंबर में कौन सा वायर कनेक्ट है, दूसरे साइड में कौन सा कनेक्ट है, उस बेसिस पे स्ट्रेट थ्रू, क्रॉस थ्रू और रोल्ड ओवर डिसाइड होता है. So normally straight through cables are used to connect PC to switch when you want to connect your PC to switch device, or PC to hub. Host means PC to hub, or router to switch, or router to hub. When these types of connections are required, you will require straight through cable. So in the straight through cable, actually what happened in this cable, so there are total 8 wire in the UTP cable. So only 4 wires are actually used. The pin number 1 of one end is connected to pin number 1 of other end. Similarly, pin number 2 of RJ45 is connected with the help of wire, UTP wire, to pin number 2 of other end. So in this way, 1, 2, 3, 6, pin number 1, 2, 3 and 6 are used in a straight through cable, and they are directly connected to corresponding port, corresponding pin on the other end. So this is the straight through cable. So with respect to color coding, because color coding is the standard, this standard has been set by EIA, TIA, Electronic Industry Association, Telecommunication Industry Association. So this EIA, TIA has set some color coding order pattern, which is known as T568A. So if you want to make a straight through cable, we must have this color coding order. It should always start with green, white, then green, then orange, white, then blue, blue, white, then orange, then brown, white, then brown. The same color coding should be connected in the same fashion. Again here at the other end, this is the UTP cable and this is the RJ45 connector. And in this RJ45 connector, we have arranged this cable in with respect to 568A standard. And the same color is also connected at other end. So in this way, you can verify that pin number 1 is connected to 1, 2 is connected to 2, 3 is connected to 3, 4, 4, 5, 5, 6, 6, 7, 7, 8. So basically only 4 pins are used in straight through cable, but other pins are also connected to make the firm punching. So this is RJ45 connector, there are 8 pins are there. So there is some general practice that this particular pin is known as pin number 1 and this is 1. So there is a clip below the RJ45 connector. So you can put this RJ45 in this way, and the pin which is farther from you, if you are holding this RJ45 connector in your left hand, the farthest pin will be pin number 1 if the clip is down in the downward position. So this is the color code. Mainly we have to focus on standard being followed or not in the industry or your organization or not. So this color coding should be followed for better troubleshooting, because it might be possible that the pin, this particular RJ45 is present in ground floor and the second end is connected to third floor, fourth floor or other building, because this cable can be extended up to 100 meter without repeater. So at least color code should be there so that while troubleshooting, we can cross verify that proper connectivity is there or not. And there is one more color coding order, which is known as EIA TIA T568B color coding. So only color coding order is different. Both order can be followed, 568A or 568B, to make the straight through cable. So it starts with orange, white, then green, then orange, then green, white, then blue, blue, white, green, brown, white, brown. So same color need to be repeated at the other end. So in this way, we will have straight through cable. And after inserting this wire, a crimping tool is required to punch this wire and pin together. So this is the straight through cable. So normally in the market, this cable is already available as a ready-made cable, but sometime we may require to prepare this cable. So this is the signal, actual signal transmission happening on the cable. Like pin number 1 is used for transmission of plus signal and other end is receiving the plus. Pin number 2 is for receiving of minus from other side. So this is TX RX combination, straight cable. There is another type of cable, crossover cable. So when cross cables are used, when similar types of same types of device need to be connected. For example, we directly want to connect a switch device with second switch, third switch. So switch to switch connection can be connected with the help of crossover cable. Hub to hub can be directly connected with the help of crossover cable. Host to host means you can directly connect a PC to other PC, a laptop with other laptop without hub or switch with the help of crossover cable. Hub directly to the switch, router direct to the host. Router direct to the host means router to PC. So we can directly connect our PC device to the router Ethernet port. So basically router is not a special device, a specialized device, but router is also a PC. Only difference is that this PC is having the motherboard, everything is there. Only it is made for a special routing function. So router is logically a PC, multi-home PC having multiple an IC card with some programs of for maintaining the routing table. So logically router to PC or router to host means both devices are logically same. So this router to host can be directly connected with the help of crossover cable, and router direct with the router can be also connected with the help of crossover cable. So so if we have the same types of device, you can have a crossover cable and you can directly connect this to switch, switch to hub or hub to hub, PC to PC, PC to router, router to router, and PC direct to PC. And this is the actual wire pairing and connectivity. Pin number 1 is actually connected to 3 of other end, 2 is connected to 6 of other end, 3 is connected to 1 of other end, 6 is connected to 2 of other end. So that is why it is known as, because these two pairs are actually crossing each other. So that is why it is known as crossover cable. And remaining pin like 4, 5, 7, 8 are directly connected in straight fashion. So basically it will create a crossover cable, and this is the color code order. If you want to make crossover cable, one side can be arranged in accordance with the 568A standard, and second end can be arranged in accordance with the 568B. Automatically, it will become a crossover cable. You can verify. One should be connected to 3. One is green white. Other end on 3 green white is there. 2 is green. It should be connected to 6. So 2 on the other end, 6 is green. 3 should be connected to 1. So 3 is orange white. This orange white is connected on 1. So in this way, we have crossover cable ready. And this is the transmission receiving signal with respect to DC signal plus minus. And there is one more cable, rolled over cable, or sometimes it is known as rolled cable, rolled over cable, or sometimes it is also known as control cable, because it is the special cable used to connect the control port of managed router or managed switch. So managed router or managed switch means a router or switch which can be configured by user, configured by administrator. So if we want to configure the router from our laptop, from our desktop PC, we need a control port. By default, normally control port is available in the router and switch device. Not only in router and switch, many devices have control port option. So our PC can be directly connected to router so that we can get the admin control or command control of router on our PC with the help of telnet program, with the help of putty control. So there are many programs are there, hyper terminal. So with the help of this, we can configure, we can see the status of router. So for this purpose, a control cable is required, rolled over cable. So it is generally used for connecting a PC to router control port or PC to switch control port. So this control port must be there, and this control port or rolled over cable is nothing but when you reverse the order of straight cable, means the other end is reversed, means pin number 1 is connected to 8, 2 is connected to 7, 3 is connected to 6. So other end is just the reverse of this order. So 1 is connected to 8, 2, 7, 3, 6, then finally 8 will be connected to 1. So in this way, we will have the crossover, rolled over cable. Now coming to devices, devices starting from hub. So hub is a layer 1 device, and layer 1 is also known as physical layer with respect to ISO OSI model. And physical layer means everything, every function defined in the physical layer from signal transmission, modulation technique, and whatever thing is defined by ISO OSI is known as physical layer device. So this hub exists at layer 1 or physical layer device, and it is also known as Ethernet concentrator or multi-port repeater. So this hub can be also treated as multi-port repeater because it also regenerates data signal which allow network to be extended to greater distance. Hub do not make any decision when data signals are received. So data signal means we are not talking electronic signals or electronic communication signal. We are talking with respect to data communication, computer network communication. So whenever we are sending any data, when we send a data, our data is divided into smaller fragment. Basically, the smaller fragment is known as frame with respect to computer data. तो हमारा कंप्यूटर नेटवर्क में जब हम डेटा के स्ट्रक्चर की बात करेंगे, this data can be transmitted in electric current, light wave, radio frequency. But with respect to computer network, this data is known as frame. So frame means frame have some information. Frame have some information: source address, destination address, and data portion. So this hub device, when a hub receive any signal from any PC, it do not make any decision because hub is not an intelligent device. They cannot read the content of frame. So that is why they cannot make any decision. So they generally do not make any decision when data signals are received. No examination of frame is performed. No forwarding decisions are made. So basically, what the hub basically after receiving a signal, after receiving a frame coming from APC, will be broadcasted everywhere. So hub के केस में चाहे मैसेज को फ्रेम यूनिकास्ट वाला फ्रेम आ रहा हो या मल्टीकास्ट हो या ब्रॉडकास्ट हो, it will be always broadcasted on every port of the hub. So hub do not make any decision. Hub exists within a single collision domain. Hub exists within a single broadcast. So this is the property of hub, that it have only one communication channel available inside the motherboard or electronic circuitry of hub, and it have single broadcast domain. Means if any of the PC or device or node send a broadcast message, it will be broadcasted to each and every PC connected to the hub. So this is the diagrammatic representation of hub, that some message is coming and this message is going everywhere from this port. So basically, when this PC is sending the signals, it is going everywhere to all the PCs, irrespective of nature of message. This message can be unicast, broadcast, multicast. It will be always broadcasted by hub, because hub cannot take any decision with respect to address mentioned in the frame. So hub is not capable, and that is why hub is treated as unsecured device, because this PC is trying to send data to PC2 only, but this message is going everywhere to PC3 also, PC4 also. So in this way, this message will be visible to every device connected to the hub device. तो यहाँ पे एक अटैकर भी हो सकता है. The attacker might capture all the traffic flowing between PC1 and PC2. So that is why hub is treated as unsecured device. It is not secure. So this was hub. Now coming to a repeater. So before going to repeater, we can have some transmission impairment. Why repeaters are used? To regenerate the signals. After traveling some distance, when we transmit electric current or radio wave in the atmosphere or through the communication channel or media, the signal become weak after traveling some distance due to various factors, due to resistance of the communication channel, due to environmental factor, due to external interference. So there are four terms are there. Attenuation. Attenuation means loss of energy, strength of signal decrease with the increasing distance. Distortion. Distortion means the shape of signal is getting distorted. There is a change in shape. And noise means some additional external signal have been superimposed with the original signal. A dispersion means signal is getting dispersed, spread due to reflection, due to refraction. So there can be any. So normally radio wave can be dispersed due to obstruction like mountain, building. So these are the four reasons why repeaters are used. So what happened? So these four parameters are reason behind transmission impairment, and that is why repeater devices are used. And due to attenuation, the distance, maximum distance, traveling distance of signal are reduced. Signal weakens as it travels, and due to the resistance of the cable or medium through which signal transmit cause the loss of signal strength. So that is why we need repeater. So depending on which transmission signal which transmission media we are using. We are using UTP cable or Ethernet cable or optical fiber or radio wave. So accordingly, we have to use the repeater device. So a repeater also operate at physical layer, layer 1. Repeater is mainly used for regenerating the signal to make the signal strong as comparable to the original signal. When the signal become weak, they copy the signal bit by bit and regenerate it at the original strength level. So any repeater have only two ports. One port is for incoming and second port is for regenerated signal for further forward propagation. So this repeater is basically a simple device which only regenerate the signal. So repeater also don't see the content of header. Content of header means it do not see the content of frame. And it is the most basic form of forwarding device. At one port, input signals are received. At other port, the regenerated signals are forwarded. Do not make any decision when data signals are received. They simply regenerate the signal. So repeater is not an intelligent device with respect to computer network because it cannot read the content of frame, source address, destination address, parity bit, but it is intelligent with respect to physical layer because it can understand what is the original signal strength, what should be the amplification voltage. So this types of understanding is there with repeater because repeater is made for regeneration of signal. They simply amplify the electrical signals. A repeater receive a frame, regenerate an exact copy of the frame and forward it along the way. Repeater exists within the single collision domain. So because a repeater is only used to extend the length of existing communication channel. So that is why last two line is actually saying that it increased the collision domain size. Before the use of repeater, the collision was happening in the 100-meter radius. After connecting repeater, the same collision can happen in the 200-meter region. Similarly, broadcast is before using the repeater, broadcast was happening within the 100-meter. After connecting, so we can extend the length of, we can extend the perimeter of our network with the help of repeater. Now coming to switch device. So switch device is very important device with respect to computer network as well as it is comparatively more secure than hub device. So switch device work at layer 2. It is also known as layer 2 device and also known as data link layer device. So switch layer 2 means data link layer. And switch has intelligence to make forwarding decision based on MAC address contained within the frame. So whenever a PC transmits data in the form of frame, this frame is received by switch. The switch will read the source MAC address, destination MAC address, and accordingly the switch will take forwarding decision that this particular frame need to be forwarded to port number 5 or 6. So depending on what is the destination MAC address mentioned in the frame. तो एक स्विच जो है फ्रेम को रीड करता है, सोर्स मैक एड्रेस, डेस्टिनेशन मैक एड्रेस को रीड कर सकता है एंड ऑन द बेसिस ऑफ दैट दे कैन मेक डिसीजन कि इसको कहां पे फॉरवर्ड करना है, किस पोर्ट पे फॉरवर्ड करना है, क्योंकि डेस्टिनेशन मैक एड्रेस जिस पीसी का होगा उसको ये भी पता है कि विच पीसी इज विच मैक एड्रेस इज कनेक्टेड टू पोर्ट पर्टिकुलर पोर्ट. More efficient use of bandwidth and increased throughput. Divide the collision domain. Single broadcast domain by default. Broadcast domain is single by default, but after configuring the virtual local area network, we will have multiple broadcast domain in case of switch. So in networking industry, we have two types of switch, layer 2 switch and layer 3 switch. Layer 2 switch means it is simply performing the intra-networking function. Intra-networking function means all devices are connected to same network. And layer 3 switch is performing the function of router plus switch. Means router plus switch. If a router plus switch is combined, then it will be treated as L3 switch. So in case of switch scenario, what happens? Whenever a frame is sent by a PC, a frame have many parameters are there. Source MAC address. MAC address means physical address. Physical address means hardware address. So this hardware or physical or MAC address is actually present in the NIC card read-only memory. So every device have NIC card, and whenever a frame is transmitted, each frame has source MAC address, destination MAC address. So switch can read the content of source MAC address, destination MAC address, and switch is also aware every time switch is receiving a frame, it is noting down that this source MAC address is connected on port 1, this source MAC address is connected on port 2, 3, 4, 5. तो इस तरह के एक टेबल मेंटेन करता है. And that is why the switch is capable of forwarding the particular message to particular PC. Like this PC is sending a message to PC number 3. So this switch is forwarding this to this PC only. It is not going to other PC. But in case of hub, this data was going everywhere. So in this scenario, switch is comparatively more secure if compared with the hub. And why switch are capable of making such type of decision? Because switch maintain a special types of table, MAC port table or bridging table, or sometimes it is also known as CAM table. CAM means content addressable memory table. So CAM table simply means a switch is noting down every MAC address connected on a particular port. For example, so this is the command prompt of a switch device. With the help of rolled over cable connected, we have connected to a particular switch, and this switch has means we have connected to control of switch. And after running this command show MAC address on the switch, it will show how many MAC address are there, and this MAC address is connected to port 49, this MAC address is connected to 44. So this types of information is maintained by a switch device. So whenever a frame is received, source MAC address, destination MAC address are mentioned. The switch will read the destination MAC address and will try to look up in the this binding table. So if this is a 44 MAC address is there, so it will be forwarded to port number 37. But there are some types of attack. अब switch के साथ भी कोई attack होते हैं, वो attack, this types of attack can make the switch to behave like a hub, which is known as CAM flooding attack. It will be covered in network security module. So a switch can be also a victim of attack, which is known as CAM flooding attack, which can broadcast every traffic in case of switch as well. तो स्विच के केस में भी हब जैसा सिनेरियो होता है अगर उस पर कैम फ्लडिंग अटैक लॉन्च कर दिया जाए. Now coming to bridge. So basically bridge is simply layer 2 device, data link layer device used to divide or segment a network. When we want to connect two different segments together, so we can use the bridge. Collect and selectively pass data frame between two network segments. So there can be 5, 10, 20 number of PC can be in one segment, and frame from one segment can be forwarded to second segment, and vice versa. Learn the MAC address of all devices present in a particular segment and port of the bridge. So basically bridge have only two ports. One port is connected to one segment, second port is connected to second segment, and each segment can have multiple number of nodes. So how many PCs are connected to port 1 and how many PCs are connected to port 2? So this type of bridging table is maintained by bridge. Learn the MAC address of device on each connected segment. build a bridging table, forward or block traffic based on bridging tables. Do not restrict broadcast traffic. So there are two collision domain in case of bridge, and there are single broadcast domain in case of bridge. Now coming to router. So router is known as layer 3 device or simply network layer device. So layer 3 means network layer. Make decision based on IP address, based on network address, based on subnet. So router make decision on the basis of IP address, source IP address, destination IP address. Switch make decision based on source MAC address, destination MAC address. And router is used to connect two or more different networks. So that is why router is also known as inter-networking device. And switch or hub, layer 2 switch or hub is also known as intra-networking device. So divide both collision domain as well as broadcast domain are the most important device to regulate traffic on the large network. Our internet is basically operating with the help of router. So there are millions of local area networks, millions of wide area networks are operational on the globe, and all these different networks are interconnected with the help of router device. These router devices are being operated by internet service provider. Many organizations are running their router in the backbone. Enable communication between two computer irrespective of their location or operating system or their country or geographical location. So router provide connectivity between network and subnetwork. So subnetwork means a large network is divided into smaller network will become subnetwork. Bridge and switch provide segmentation within a single network or subnetwork. So basically bridge or switch or hub provide intra-networking connectivity and router provide inter-networking connectivity. So if we see this table with respect to repeater, hub, bridge, switch, router, L3 switch, we can compare with respect to intra-network forwarding, inter-network forwarding, form a collision domain, form a broadcast domain. For example, repeater. So repeater can forward signal in the same network. Same network means in the same intra-network. So that is why it is showing as intra-network forwarding. Hub is also intra-network forwarding, and other properties are not available in case of hub. It is not an inter-networking device. It does not have any collision domain. Multiple collision domain नहीं होता है. Broadcast domain भी इसमें एक ही होता है. That is why there is no check mark is there. Bridge also have intra-network forwarding property, but no inter-networking, but form a collision domain because bridge have two collision domains. So that is why it is mentioned as a form a collision domain, and broadcast domain is single. Switch means we are talking about the L2 switch. A plain switch means normally switch is considered as layer 2 device. But if you are mentioning the L3 switch means this is a special switch having L3 plus L2 capability. So switch L2 switch have intra-network forwarding property, no inter-network property, form collision domain, and by default it have only single broadcast domain. But after configuring virtual LAN, if this switch is managed switch, so there are two types of switch, managed and unmanaged switch. managed switch can be configured. Unmanaged switch cannot be modified. Their property cannot be changed by administrator. So this is a standalone switch. But managed switch can be configured and administrator or user can connect to the switch console and can configure virtual local area network. So if there are multiple VLAN created inside the L2 switch, then broadcast domain can be also divided in case of L2 switch. Router, router is inter-networking devices. It have multiple collision domain. It have multiple broadcast domain. L3 switch is the special switch having routing capability and switching capability. It means L3 plus L2 both functions are available in L3 switch. So it can have intra-network forwarding. It can have inter-networking forwarding. It can have multiple collision domain. It can have multiple broadcast domain. So now coming to OSI reference model. So this topic is very important. This topic is very important, OSI reference model. In 1984, International Organization for Standardization, ISO, developed the OSI reference model. And as per ISO OSI, the entire network functionality can be divided into 7 layers. Starting from top layer is application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. Physical layer is the bottom layer, layer 1. And application layer is layer 7. Presentation layer is layer 6, session layer is layer 5, transport layer is layer 4, network layer is layer 3, data link layer is layer 2. So OSI stands for Open System Interconnection. So why this model was treated as Open System Interconnection? Because this model was proposed for all types of, for all vendor, all types of networking equipment. It was open for all types of networking equipment. Equipment plus software plus hardware. OSI consists of 7 layers. So OSI was basically documented to ease the understanding of complex TCP/IP software. So the complex networking function from PC to PC communication or any network communication can be divided into 7 different layers. So ISO developed the 7-layer model to help vendor, network administrator, software developer, system programmer, or OEM manufacturer or operating system developer to gain the better understanding of how data is handled, transported between networking device, between two device, between device PC to router, how router to router is communicating. So every communication was simplified in the form of 7 layers. So there are different protocols with respect to application layer can have some set of services, some set of protocol. Some services are running on a physical layer, some are running on data link layer. So there can be categorization with respect to this 7 layer. So basically OSI reference model defines the process for connecting 2 layers together, promoting interoperability between vendors. So during that development phase of TCP/IP software, everything was very complicated. To simplify the interoperability between 2 different vendors, 2 different operating systems, 2 different software, the ISO OSI model was documented and proposed by ISO. Separate complex function into simple component, each implementation and simplified troubleshooting. Provide a teaching tool to help network administrator understand the entire communication process between networking component. Allow multiple vendor development through standardization of network component. Allow various types of network hardware software to communicate. Prevent changes in one layer from affecting other layers. So it does not hamper the development. It means ISO-OSI reference model was framed to control the development operation also. Suppose a hardware manufacturer has changed something in the hardware parts, like suddenly we decided to switch from wired network to wireless network. So it doesn't mean that we need to change our operating system, we need to change the entire application software. Or a programmer cannot force the customer or user to change the hardware just because they have implemented something which do not support wireless or wired or something like this. तो मतलब ये है कि कोई एक लेयर में जो काम हो रहा है उसमें कुछ चेंज होगा तो उसका इम्पैक्ट दूसरे लेयर पे नहीं आना चाहिए. अगर हार्डवेयर में चेंज हो रहा है तो उसका सॉफ्टवेयर पे कोई इम्पैक्ट नहीं होना चाहिए, उसका सिस्टम सॉफ्टवेयर पे कोई इम्पैक्ट नहीं होना चाहिए. Similarly, if there is change made in the system software, it should not impact the application layer, it should not impact the physical layer. ऑपरेटिंग सिस्टम अपग्रेड हो गया तो इसका मतलब नहीं कि हार्डवेयर आप बदल दो, अब ये वायरलेस का ये मॉडल नहीं काम करेगा, ऐसा नहीं. So everything is developed in standard and control way with reference to ISO OSI reference model. So ultimately summarizing the ISO OSI objective: interoperability, compatibility, simplification, modular design and training. So normally when you work in computer network scenario, you have to visualize every concept, every communication process with respect to this 7 layers. So this problem is related to application layer, or this problem is associated with transport layer, or it is a physical layer problem, or it is a layer 3 problem. Similarly, while making the security decision in firewall or UTM device or intrusion detection system, you have to decide this particular security device software or firewall or IDS or SIM software is applying policy or rule for on application layer basis or network layer basis or data link layer basis or transport layer basis. So we have to go through all the layers with respect to network communication, with respect to cyber security scenario. And the real ISO OSI reference models is documented, available on the ISO website in the form of ISO IEC 74981. The basic models are covered in. So this is the documented. This is the PDF document. You can go to the ISO website where you can find the actual ISO OSI reference documented model. And this is the second paper, which is explaining the security architecture of all the aspects of computer network. And the third is related to naming and addressing concept and standards are mentioned in the 74983. And the last one is 4 is management and framework related resource are covered in this document. And the last one is also having some International Telecommunication Union recommendation for Act 200. So basically there are many standards are there, and these standards are defined in very well documented way in the ISO reference model. So you can go through this ISO SI reference model, and this is the layer wise naming. Layer 1 is physical layer and layer 7 is application layer. Now coming to each layer, what is the function of each layer? How many protocols? How many services are there? Which types of services are related to particular layer? So application layer, as the name indicates, application layer is the layer which provides the application services, particular application services for the user for the networking application. This layer provides the protocol services application need to take advantage of a network. For example, DNS, domain name system, DHCP, dynamic host configuration protocol, telnet, SSH, secure shell, FTP file transfer protocol, HTTP, Hypertext Transfer Protocol, HTTP, POP3, SMTP, SNMP. So there are many protocol services are there. So these protocols are working at application layer because these protocols are providing the specific application to take the advantage of network. For example, DNS. DNS is a domain naming system, which is providing the name resolution services. So whenever we are typing www.google.com, this DNS is providing some IP address to our browser. Because in computer networking, hardware to hardware communication happen over the MAC address. Physically, each hardware identifies a remote hardware with the help of physical address. But software present installed in our machine communicate to software installed on remote machine in logical way with the help of IP address, logical address. So software to software communication happen with the help of IP address, and hardware to hardware communication happen in physical way with the help of MAC address or physical address or hardware address. Because data need to be physically traveled through the wire, through the radio frequency, radio system. So physically they can be transmitted to the destination machine with the help of their physical address. But logically it should be reachable to the remote software running on the remote machine. So DNS provides the name resolution service because as a user we cannot remember the IP address of every system running on the globe. So it is better to use some user-friendly naming system like www.google.com, www.dot.gov.in, irctc.co.in. So it is very easy to remember. So this domain naming system was implemented for user being, for ease of human being. But in the background, software is running. Software will need IP address. Again, after that, hardware is running. So hardware will require the MAC address. So there should be some service which can resolve this domain name to IP, IP to MAC address to IP address to domain name. So this types of name resolution service run in the background. So DNS provides this service. So there is an explanation of each protocol. So this is the very limited list of protocol. There can be more than 1000 protocols are there in application layer. So depending on which application you are using. But these are the some common protocol like HTTP, Hypertext Transfer Protocol, which is used to browse the web page. FTP means file transfer protocol, which is used to download or upload a file from a remote FTP server. SMTP means simple mail transfer protocol. It is used to transmit the email, send email from email server to other email server, or from mail user agent to mail server. POP3 means post office protocol version 3. This protocol is used to receive the mail. So whenever we are logging to our email client software like Outlook Express or gmail.com web-based email client, we are pulling the message with the help of POP3. All the incoming email message being pulled with the help of POP3, or there is one more protocol, IMAP. IMAP is not listed in this slide, but there are two types of email receiving protocol, POP3 and IMAP. So IMAP is more flexible. POP3 is having limited functionality. NTP. NTP stands for Network Time Protocol. The Network Time Protocol is a special protocol which provides timing service to the client machine. So basically it is a NTP server which provides the clock, which provide the time, accurate time. In this way, all the devices are synchronized with the single centralized timing. So this NTP is very important with respect to our cybersecurity scenario, because asynchronous or different clock on node will create different logs, because we are storing the logs of logged on each system, or our security system like SIM system or log monitoring system is maintaining the log. What will happen if all devices are having different time? So there will be some mismatch in the log, because the security system generally use agent modules on each client device. So each client device can send the wrong clock information. It might be possible that my computer is running, current time on my computer is 3:05 p.m. but on some other computer it is 3:10 p.m. or some may have 3 a.m. due to wrong timing configuration. So this problem can be resolved with the help of NTP server. And as per the guidelines of CERT-In, CERT-In is a nodal agency which is responsible for coordination of all the network cybersecurity incident, cybersecurity related advisory guidelines are released by CERT-In agency. So this CERT-In has recently advised all the industry, all the company organization to use the standard NTP server to maintain a uniform log. So this NTP is a special protocol of application layer. Coming to SNMP, simple network management protocol. So we generally use network monitoring software, network management software. So how this network management software or monitoring software works? How they get the status of remote computer running in our organization? 500 computers are there. So all these 500 computers are basically sending some message with the help of SNMP, Simple Network Management Protocol. So this SNMP is helpful for NMS, Network Management Software or Monitoring Software. TFTP is a light version of File Transfer Protocol, TFTP. DNS, Domain Name System, which is helpful for translating the domain name to IP address to domain name. Not only domain name to IP to domain name, there are different types of, various types of resource record present in the DNS server. It will be covered in next slide. DHCP, Dynamic Host Configuration Protocol. So when you assign IP address, suppose I am going to my network card property NCPL NCPA dot CPL. So this NCPA dot CPL will open the graphical interface to my NIC card. So these are the lists of NIC card present on my laptop. So there are many types of NIC card appearing. One is Bluetooth network connection. Second one is wired NIC card. Third one is virtual NIC card. Fourth one is also a virtual connection, VPN connection interface. Fourth one is also VPN interface. Then again there is a VPN interface. Then VMware, some virtualization software is running on my laptop, so which has created a virtual NIC card on my laptop. Similarly, there is one more virtualization NIC card is there. Then Wi-Fi NIC card symbol is also appearing here. Currently my Wi-Fi is disconnected, that is why it is showing red cross. And this is my wired network. So we have to configure to get connected in the computer network. We must have some IP address configured on our NIC card. For example, this is my wired NIC card, which is a regular network of my organization. By right-clicking this NIC, we can have property. So there are many options are coming. IPv4. When selecting this IPv4 and seeing the property, it will show the IP address. So there are two options: obtain an IP address automatically, and second option is coming as use the following IP address. So this IP address has been manually configured on this laptop. So this is the static IP addressing which is configured by user or administrator on this laptop. There is this option is basically used for DHCP. Obtain IP address automatically means If your organization or administrator is running a DHCP server in your network, your machine will automatically get IP address, subnet mask, default gateway, DNS server information. Similarly, DNS server is also configured manually. We can select this option also. So if a DHCP server is running in my network, my computer will get automatic IP address from the DHCP server. So DHCP server make administrator job easy by automatic provisioning of IP address to different computer. So this DHCP is also a application layer protocol. So when configuring a DHCP server, administrator will provide the range of IP address to be distributed, default subnet mask to be distributed, gateway to be distributed to the end use machine, DNS server information to be distributed to the end machine. End machine means DHCP client machine. After selecting obtain IP address automatically means the computer will become DHCP client. Similarly, telnet is there. So telnet is used for remote terminal. We can execute the command from our remotely from our laptop. Suppose I am making telnet connection to remote computer located in Delhi. So after making telnet session with the Delhi computer, I can execute some of the command on my system, but it is virtually executing, virtually running on my laptop, but it is actually executing on the remote machine because I am getting the virtual console of remote machine with the help of telnet protocol. Similarly, SSS is there. So there are many types of SSS is secure version of telnet. Telnet is not secure. When you try to telnet to remote computer, your every transmission, every communication will be visible in clear text because everything is transmitted in clear text, including username, password, and all the commands executed on the telnet. So that is why telnet is not used in WAN level. Alternate version is secure shell. Secure shell encrypts everything between client machine and server machine. Now coming to presentation layer. Presentation layer is the sixth layer. Layer 6. Presentation layer is mainly concerned with the syntax and semantic of the information that is going to be exchanged between two computers. Syntax, how the data will be transmitted, what will be the encoding scheme, what will be the compression method, what will be the encryption. So all these parameters are associated with presentation layer, how data will be presented, how data will be prepared, how data will be transmitted, what will be the format of data, what will be the format of data to be delivered to the target application software. So there can be different standard protocol like ASCII, BMP, GIF, JPEG, WAV, AVI, MPEG. So these are the limited list. So basically presentation layer provide the translation service because at application software layer, we are using, suppose we are using bitmap or we are having MP3 file or MP4 video file. So many times when we are transmitting this video or image file or any file, this needs to be translated to some standard format which can be transmitted over the communication channel. So these translation services are provided by presentation layer. Encryption, decryption services are also provided by presentation layer. This encryption, decryption are also a part of application layer. A developer can implement their own encryption, decryption mechanism at application layer as well. But natively, some of the encryption, decryption methods are available at the level of system software, which is provided by presentation layer. Compression, decompression. So data, original data is never transmitted in original format, because original video file, original image file size are generally big size are there. So we need to compress this file so that our less bandwidth will be consumed. To reduce the bandwidth consumption, all the data between two computers, sender and receiver, are transmitted with the help of some compression algorithm, compression technique. For video, there are separate algorithm. For audio, for image, for text, there are different compression algorithms are there. Session layer, layer 5. So session layer is used to establish, maintain, and synchronize the interaction between two communicating devices. How the data, how the connection will be initiated, how the connection will be set up, how the connection will be maintained, how the connection will be closed, tear down, graceful closing of connection. All these are the responsibilities of session layer. Session layer maintain the data of separate session. So it separates the different data, different session data separate. Means if we have opened multiple websites from our browser, suppose we have google.com, youtube.com, email.com, everything is open on my machine. So this data, whatever data is coming to my system, should be specific to particular application. If my computer is receiving data of gmail.com, it should be visible in only gmail.com tab. So different session data should be separated. So this role is performed by session layer. So there are many types of protocols: RPC, remote procedure call, NFS, SQL, ADSP, ASP, control protocol for multimedia communication, Sept, ISO SP, H.225, ISO 8327, ISNS, NetBIOS. So these are the list of protocols which provide the session layer functionality. Dialog controls are maintained by session layer. Synchronization, session layer also add some checkpoint to synchronize the data being received. Coming to the most important layer, because you are going to learn the cyber security topic, so we should be aware that our encryption is actually happening between two routers, or it is happening between two applications, or between transport layer to transport layer, or between network layer to network layer, or between data link layer of sender machine to data link layer of remote machine. So your encryption mechanism should be clear that our data is encrypted at end-to-end encryption is implemented or not. So our data is secure from web browser to web server, or it is getting secured after some other point. So this type of analysis should be done by you. So transport layer, coming to transport layer, it is a layer 4. Transport layer is the layer which provide end-to-end delivery between two machines, not between application to application. It basically actual handover takeover process just after the application. Suppose we are typing something in the browser. So our browser is handing over the data to transport layer. Finally, transport layer is getting communicated to the remote transport layer of remote machine. So that is why it is known as end-to-end communication happen over with the help of transport layer. Transport layer end-to-end communication provide करता है. लेकिन end-to-end encryption नहीं, इसका मतलब end-to-end encryption नहीं हुआ. End-to-end encryption means we are securing our data starting from application like WhatsApp, like web browser, and it is completely secured way application machine. Coming to transport layer provides both guaranteed data delivery as well as no guarantee of data delivery. So transport layer basically provides two types of communication. One is guaranteed communication and one is without guarantee. Why there are two types of communication when there is a guarantee of data delivery mechanism? So why we are using the no guarantee mechanism? Because no guarantee mechanism provides the faster communication, but the guaranteed data delivery will have some overhead. Due to this overhead, these communications are generally happen in slow pace, but it is reliable. So there are two protocols exist on the transport layer. One is TCP and second one is UDP. So TCP provides the guaranteed delivery of data and UDP provides no guarantee of data delivery. But UDP is faster, TCP is slower. With our Cisco WebEx communication happening with all the participants, actually my voice, my video stream, my screen is actually going through the UDP protocol. But some part reliable connection which require reliable connection like control signals and some other part essential critical components are happening over the TCP protocol. So it depends on application, it depends on the software developer, system software developer, which protocol they are implementing in their mechanism. If they want reliability, then they can use TCP. If they want little delay in the communication, they can use UDP. Even after using the UDP, the application programmer have an option to implement some reliability mechanism at the level of application programming level or application layer level. तो UDP यूज करने के बाद भी एडिशनल कुछ अपने लेवल से भी प्रोग्रामिंग करके कुछ गारंटी वाली सिनेरियो हम कंफर्म कर सकते हैं, इंश्योर कर सकते हैं. So it depends on, entirely depends on the programmers, what they are going to use. When we visit the website like https or http.google.com, something like that, so we generally use TCP protocol for transferring of web page. Whenever we visit the website, our every page comes to our system in the form of TCP data. When we make query with the DNS server, like what is the IP address of www.google.com, so this types of query goes with the help of UDP protocol. Where the faster performance is required, UDP will be used. Where the reliability, 100% reliability is required, then TCP need to be used. So coming to functions of transport layer, service point addressing. So basically, service point addressing is the address of a service running on the remote computer. So in computer network, there can be different types of address: domain name, IP address, MAC address, port number. So basically, port number is the last point from where we are handing over or taking over the data from application. Suppose there is a housing society located in Gorakhpur and someone is coming from Lucknow. So first he will note the physical location of Gorakhpur. So they have to catch a train or bus which can take him to Gorakhpur. After traveling to Gorakhpur, physically the person has reached the Gorakhpur, and after that they need some logical addressing like colony name, housing society name, the particular address, house number. After reaching the house number, they have to further identify it. On this house number, there are many rooms are there, many flats are there, many floors are there. So which particular floor we need to go. Similarly, when we are communicating to the remote computer, my computer is remotely identifying with the help. As a user, we are identifying the remote computer with the help of domain name. हमारे पास domain name होता है, but our software like web browser or Skype or WhatsApp, they will require IP address in the background. So DNS server will provide some IP address. On the basis of this IP address, my software will make communication with the remote machine. But again, my machine, my physical machine, my NIC card will require the physical address of the NEC device, our switch device or NEC device. So what is the physical location through which my data will be going to be traveled? Finally, when my data reach to the destination, on destination machine, there are many rooms are there, many doors are there. So which particular doors or room we need to enter? So similarly, in computer network, there are many services are running on the remote machine. तो each services is associated with पोर्ट नंबर. हर सर्विस का एक पोर्ट नंबर होता है. अगर वेब सर्विस होगा तो वो किसी एक पोर्ट पे रन हो रहा होगा, वीडियो सर्विस होगा तो वो किसी पोर्ट पे रन हो रहा होगा, DNS होगा तो DNS किसी पर्टिकुलर पोर्ट पे रन हो रहा होगा. And this port is known as service point addressing. And that is why finally you are delivering your data to the right person, because you are delivering your data to right port number. So that is why transport layer is known as provide end-to-end delivery. एक कोरियर वाले ने एक पर्सन को हाथ में पैकेट दे दिया और सही पर्सन को पैकेट दे दिया तो मतलब एंड टू एंड डिलीवरी हो गई. फर्स्ट फ्लोर की जगह सेकंड फ्लोर वाले पर्सन को दे दिया तो रॉन्ग डिलीवरी हो गई. तो ट्रांसपोर्ट लेयर इंश्योर द करेक्ट एंड टू एंड डिलीवरी एंड फाइनल डिलीवरी विद द हेल्प ऑफ TCP और UDP. So service point addressing means the particular address present, logical address present on the remote machine or source machine. So basically it is port number. So port number means logical number. Logical port is assigned by TCP/IP software. Segmentation and reassembly. Transport layer provides the segmentation of data, and when data is segmented, this needs to be reassembled at the recipient end. So this reassembly and segmentation is done by transport layer. So our original data, we are trying to download 1 gigabyte of movie from some website, but this movie, this file, this software is getting divided into several segments, and one by one this segment is coming to my PC. Finally it needs to be assembled. So this is the role of responsibility of transport layer. And this segment needs to be traveled in sequential fashion, sequential manner or unsequential manner. It depends on which protocols we are using, TCP or UDP. Connection control. Connection is also controlled at transport layer. Some connections are connection oriented, some connections are connectionless. For example, TCP is connection-oriented protocol. So before transferring any data with the help of TCP will first make a session, make a connection to the remote machine. After making the connection, the data transfer will begin. UDP do not depend on any connection. UDP randomly send the data to the target machine. So UDP is connectionless protocol. And flow control. Flow control is also a function responsibility of transport layer. What will be the transmission rate of data transmission from my machine to remote machine? What will be the transmission rate for receiving the data? So this transmission dialogue or also happen behind in the background to control the flow rate of incoming or outgoing data. तो आउटगोइंग इनकमिंग किस स्पीड से होगा वो सब भी इस पे डिसाइड होता है. एरर कंट्रोल भी होता है. तो इफ transport layer have received some corrupted data, they can control the error. They can detect the error, they can correct the error. They can send the request to resend the data. So transport layer have following responsibility: end-to-end delivery, addressing in the form of port number, service point addressing, reliable delivery with the help of TCP protocol, flow control, multiplexing, This multiplexing is not related with physical layer multiplexing like TDM, FDM. This multiplexing is associated with multiple data streams are finally combined into a single stream with the help of software communications. Reliable delivery is achieved with the help of error control, sequence control, loss control, duplication control. But these properties are actually exist with TCP protocol only because UDP cannot provide flow control. UDP do not have reliable delivery option. UDP do not have error control mechanism. UDP do not have a sequence control mechanism. UDP do not have loss control mechanism. So UDP is very simple protocol. And that is why it is very fast. There is very little bit delay is associated with UDP communication. But TCP is 100% reliable, but it is slow in comparison to UDP. So TCP is a reliable protocol. It always have positive and negative acknowledgement. If data is received properly, a positive acknowledgement signal is also sent. If something went wrong with the received or sent data, a negative acknowledgement is received or sent. TCP ensures the data reach intended destination in the same order it was sent. So basically TCP sends data in sequential manner. There is some sequence number assigned by TCP protocol. So entire data is divided into smaller segment. Each segment has some sequential number. So one by one, they reach to the destination machine in sequential fashion. TCP is connection oriented. To TCP, before transmitting any data, TCP will first make the connection. After establishing the connection, the data transfer will begin. TCP provide error checking and recovery mechanism. TCP provide end-to-end communication. TCP provide flow control and quality of service mechanism. TCP operate in client-server point-to-point mode. TCP protocol have client-server option. They can make simultaneous connection from single port. Mean if a web service is running on port 80, this particular port can make connection with multiple unlimited number of users accessing the website. It can make point-to-point connection. It can make client server. It can be run in client server model. Multiple user can make to the same port on the target machine. TCP provide half a full duplex server. It can perform role of both receiver and sender. So TCP is not a hardware, TCP is a protocol, and TCP is implemented in the form of TCP/IP software. So there is some modules are associated with TCP, and TCP can receive data at the same time from the same port. It can act as a receiver, it can act as a sender also. So this TCP, this UDP, HTTP, all these protocols must be fully understood by person who want to build a cybersecurity profile, because while making the firewall rule, while making the intrusion detection system rule, or while implementing some policy, we need to make policy on the basis of this protocol. Not only on the basis of user, but this user will be allowed to access TCP or UDP. They will be allowed to access the particular port or not. If traffic is coming to port number 9090, it should be allowed or blocked. So this type of understanding should be there. तो पोर्ट का नॉलेज होना जरूरी है. आईपी एड्रेस, मैक एड्रेस, डोमेन नेम, यूजर एक्सेस कंट्रोल, नेटवर्क एक्सेस कंट्रोल, सारी पॉलिसी सब कुछ मिक्स होंगे आगे जाके. If you are going to block something, you should be aware that this particular service is dependent on TCP or UDP. So if it is a UDP, if it is using UDP, it means we have to make appropriate rule for the UDP protocol. Coming to UDP, UDP stands for User Datagram Protocol, and TCP stands for Transmission Control Protocol. UDP is used when acknowledgement of data does not required, does not hold any importance or significance. UDP is good protocol for data flowing in one direction. You just want to throw something to the remote machine. You do not want acknowledgement, you do not want any response. Then the UDP can be used. UDP is very simple and suitable for query-based communication. UDP is not connection-oriented. UDP does not provide congestion control mechanism. There is no flow rate mechanism. UDP does not guarantee order delivery of data. UDP में डेटा रैंडम तरीके से पहुंचता है, एक साथ 10 सीक्वेंस ऑफ डेटा यूडीपी के थ्रू फ्लड कर दिया गया, वो वहां पे उस सीक्वेंस में पहुंचेगा ये कोई गारंटी नहीं है, और वहां सीक्वेंस मैटर भी नहीं करता है. So this UDP used only where sequencing of data doesn't matter, doesn't hold any significance. UDP is stateless protocol. Yes, there is one more term, stateful and stateless. TCP is stateful protocol. Stateful protocol means it remembers the previous session, it remembers the previous sequence number. Because every time a TCP data is sent, TCP protocol is aware that I have received data up to this number and I am waiting for this number. Similarly, the recipient end will also remember that this particular data I have already received. Now it is supposed for next data from starting from 501, 502 like that. So TCP is a stateful protocol and UDP is a stateless protocol. There is no states are maintained. TCP maintains the state. UDP is suitable protocol for streaming applications such as VoIP, video conferencing, multimedia streaming, video streaming. So this TCP and UDP is important with respect to cybersecurity because while making the connection, TCP follows some pattern. TCP sends some special signal. This special signal needs to be learned because this special signal can be misused by attacker. And after misusing this particular sequence combination, the attacker can launch different types of attack on the remote machine with the help of same TCP or UDP protocol. So actually what happened in the TCP or UDP, for example, this is the sequence of UDP. So there is no any state is mentioned because it is a UDP protocol. So normally there is no advanced connection is made in UDP. UDP do not require any advanced connection. It is directly communicated with the help of some message. For example, some message is transmitted to this machine and accordingly some response are coming. There is no previous special signals are sent. Directly communication data is sent to the target machine. So UDP, unreliable delivery, no error checking, no flow control, no congestion control, no order delivery, no connection establishment. In case of TCP, before transferring any data. In case of UDP, data is directly sent to the target machine. This is data, this is indicating data. But in case of TCP, before sending any data, three-way handshake method are used. Three-step procedures are followed, starting with chain signal. A chain synchronization signal is sent to the target machine for making request, for making a stable connection. So a chain signal is sent to the target machine. After that, when receiver is ready, receiver will send a positive signal, SYN acknowledgement. So this receiver is actually sending two signals, SYN plus acknowledgement for first SYN signal. After that, final acknowledgement is sent. After completing these three steps, the connection will be established, and after that, the actual data will be transferred. So TCP reliable delivery, error checking mechanism, error detection mechanism, error correction mechanism, flow control, congestion control, ordered delivery, connections are established by sending this signal. So actually what happened in the TCP, there is a special term used in TCP, three-way handshake. So this three-way handshake is very important for our cybersecurity because this three-way handshake will be used at many levels in different modules. So this three-way handshake is a normal practice followed by TCP protocol. Before sending any data, first establish the connection. To establish a connection, we must initiate with some signal process, which is known as three-way handshake. So first start with synchronization signal to be sent to the target machine. After that, we will receive some acknowledgement. Then finally, we need to send a acknowledgement signal to finalize the three-way handshake. So you can see this diagram. Here, two computers are there, sender and receiver. Sender will say, I want to connect to you. My initial sequence number is 100. So it is starting with some sequence number. Randomly, a sequence number is allocated by system software. So it is sending some signal. Sequence is equal to 100. Control signal is equal to SYN. SYN means synchronization signal is being sent to the receiver. After receiving this signal, receiver will reply, I hear you. My initial sequence number is 1. Because it is this receiver machine is also starting the fresh communication. So it will also have some sequence number for their own communication. तो हर कंप्यूटर का अपना एक सीक्वेंस नंबर होगा. तो अगर एक डेटा जाने के बाद दूसरा इंक्रीमेंट होगा, फिर दूसरा जाएगा तो तीसरा, चौथा, इस तरह से फर्स्ट कम्युनिकेशन, सेकंड कम्युनिकेशन, थर्ड सीक्वेंस नंबर, फोर्थ सीक्वेंस नंबर. Similarly, receiver also generate their own sequence number. Sequence equal to 1. This is my sequence data, one number sequence. I am sending acknowledgement for 100. Your data with sequence number 100 is received with me, and I am ready for 101. So this 101 means I have received your 100. I am ready for next data. It means 101. And it will send two signals, SYN plus acknowledgement. Acknowledgement for this data, जो पहला डेटा आया था उसका acknowledgement, और this SYN for इसको अपना भी connection establish करना है. तो this receiver is also getting connected to this sender machine. So it is also sending the SYN signal. So first is SYN, then SYN plus ACK, then finally this machine will send the acknowledgement signal for completing this three-way. Now this machine is replying that this is my new data, means third step, sequence is equal to 101. Acknowledgement 2 means I have received your sequence 1. Now I am ready for your next sequence 2. By sending acknowledgement 2 means I have received up to 1. After that, I am ready for receiving the next sequence of data from your side. And control signal is sent acknowledgement. So after completing this 3 step, TCP connection is established. After that, data transfer actually begin. तो TCP में ये 3-way हैंडशेक होता ही होता है. ये स्टेप UDP में नहीं होता है. तो ये अंडरस्टैंडिंग होनी चाहिए कि एथिकल हैकिंग में because you are learning ethical hacking, it means you should have clear understanding about the TCP, UDP, every type of protocol in the computer network. Because this sequence number can be manipulated. This control signal can be misused. Now coming to TCP sliding window. तब तक हम लोग कुछ क्वेश्चन सेशन पे चलते हैं. One minute. So this three-way handshake is very important. You should remember the first part is SYN signal. After sending the SYN signal, we will receive SYN plus acknowledgement from the receiver side. Finally, the third step will be SYN signal to the recipient machine. So this three-way complete step will create a three-way handshake, and after that, connection will be established by TCP protocol, and then data transfer will begin. And the same SYN signal can be manipulated, misused by the attacker for launching denial of service attack. Infinite number of SYN signal can destabilize, can make the service down due to dependence of CPU, due to heavy usage of CPU memory on the target machine. तो यही SYN signal से DOS attack भी launch होता है. And by seeing some of the sequence number, some of the parameter pattern, one can predict the operating system running on the target machine. Because each operating system has some unique footprint. They can show some fingerprint on the basis of their version, on the basis of their operating system. A Linux machine can return some other fingerprint. A Windows machine will show some other parameter. So by seeing this parameter, by seeing this fingerprint, one can come to conclusion that remote machine is running with Windows Server operating system or Linux operating system or Mac, or it is something else. It is a Cisco device, or it is a Windows device, or a Linux device. So this type of fingerprinting is done by an attacker. So this guessing technique can be helpful for attacker. And by using the common identification technique from three-way handshake, by reading the sequence number, by seeing the size of control signal, so there are many parameters are there. It will be covered in network primer 3. TCP sliding window. TCP sliding window is the method which control the flow rate between sender and receiver. So this sliding window algorithm or protocol or service is basically meant for only TCP protocol, because flow rate is only available in controlling is only available in TCP protocol. But UDP do not have any sliding window method. So with the help of TCP sliding window protocol, the sender and receiver can adjust the window size. They can reduce the size, they can increase the size to increase their transmission rate, to slow down their transmission rate. And on the basis of default window size, a attacker can predict, can guess the operating system, the target machine running on the target machine. Just by capturing, just by seeing the default window size, they can predict the target OS, they can predict the target machine. So TCP sliding window protocol works something like this. Suppose sender wants to send something to the receiver machine. So it will start something like this. My window size is 7. So I am sending you data from sequence number 10 to 16. Sequence 16, sequence 7, 10, 11, 12, 13, 14, 15, 16. So total 7 window were transmitted from sender to receiver. So window size is 7. Now after receiving this message, receiver will reply something like this. I hear you, my window size is only 3. There can be many reasons behind this, why window size is 3. It might be possible that receiver is busy in handling some other data. So they can reduce their window size, or their operating system can have different window size. So depending on what is the window size, default window size, or window size has been decreased or increased due to status of current incoming or outgoing traffic. So this window size can be reduced or increased. So currently receiver is replying with my window size is only 3 right now. So I had to drop everything after 12. So I will receive 10, 11, 12, and 13, 14, 15, 16 will be dropped by me because I am not in position to receive all this data. So it will be replied back with something like that, sequence equal to 200, because sender has already sent the sequence number 10, 11, 12, something 15. Now this machine is replying this message with their own sequence number 200. Acknowledgement 13 means I have received data up to your data up to 12 sequence number. Now I am ready for 13, and again my window size is only 3. So this is the reply message sent from receiver machine. So then this sender machine will reply, I hear you, my window size is still 7. I am not going to reduce this to 3 because I am free right now, or my operating system is having this default window size. I got your 200, I have received your 200 message, and I am forwarding you 201. I am ready for your 201, and here are the 13, 14, 15. Now, the sender will send 13, 14, 15, and acknowledgement 201 means your previous message with sequence number 200 have been received, and window size is, my window size is still 7. So this is the way of TCP sliding window mechanism. So this window size can be helpful for attacker because this is not the real window size. Actually, this window size have different values. Sometimes window size value is 1024, sometimes it is greater than 1024. So on the basis of that, one can predict this is the Windows or Linux operating system. Now coming to most important addressing service address point. This service address point is port number of transport layer. Both TCP and UDP, both protocol use port number. So TCP communicate between two remote hosts by means of port number. It means if I am connected to any website, my local port is actually communicating to remote port. If I am making query with the DNS server, what is my IP address of yahoo.com? So my computer is sending this request from some port on my machine, and it is sending request to the target machine port number. So end-to-end connection happen with the help of this port number. So this port number actually exists at transport layer. So both UDP and TCP use port number. So it depends which application, the application is using TCP or UDP. Accordingly, the appropriate port number will be used by the application. So port number are divided into range by INA. INA is a organization, is a body which is regulating the IP address distribution, port number, autonomous system number, domain name. Every number and naming resources are controlled by INA, Internet Assigned Number Authority. So INA is headquartered at Geneva in Switzerland. So INA has defined the three types of port range starting from 0 to 1023. It is known as well-known port for a standard common TCP/IP application and function. Then second category is 1024 to 49,151. Then the third category is, so second category is used by application built by company. So if a company wants to register some port for their application, they have to apply with the INA that we are having some software and we want to allocate some of the specific port for this application. So company, the vendors need to apply for the particular port number with the INA. Then INA will register their port, this port number for a specific application. So this port number line between this series are known as registered port for a particular application. For example, 3389. 3389 is a port used by Microsoft Remote Desktop Protocol. Similarly, 3128, 3368. So these ports are used by proxy service, Squid proxy service, or MySQL server. So every application has been assigned registered port, and some of the standard application like HTTP always configured by default, always configured on port 80, HTTPS 443, Telnet 23, SMTP 25. So these are the standard ports defined by the INA. So it is not mandatory to run the service, HTTP service or SMTP service on port number 25. The administrator can change the default port for a particular application. But by default, it is supposed that the standard application must be running on some standard port. And in addition to this first two categories, there are third category which is private port, dynamic port, unregistered port. So these ports are freely used by any application or for dynamic purpose, for private purpose, no licensing required, no registration required, no conflict will be there. So normally when our computer make any connection to the remote system, remote website, our machine generally use this port for making connection request. So this is the well-known port, and this is the registered port, and this is the private or dynamic port. So these are the list of some port, TCP and UDP port. For example, FTP, File Transfer Protocol, use TCP port number 20 and 21. So there are two ports used by FTP protocol. 21 for making connection for sending the control signal, and 20 for transferring of data in FTP. Telnet use TCP 23 port. It means Telnet is using TCP protocol and it is running on 23 by default. SMTP, Simple Mail Transfer Protocol, 25 TCP port. DNS 53 TCP port. Now this DNS is appearing at both places, under TCP also, under UDP also. So what is the reason behind this? Why DNS is running using both TCP, UDP 53 number? So this 53, TCP 53 is different and UDP 53 is different. It is not same port. Both are different ports. So when DNS use TCP53 port for zone transfer, DNS is used for name resolution service. So as a client, as a DNS client, we make query with the DNS server that what is the IP address of yahoo.com. So DNS server will provide some answer, but this types of query and answer happen over DNS UDP port 53. When TCP 53 is used, because this DNS server are providing the services and there are many DNS server are running. So one DNS server is categorized as primary DNS server and backup DNS server are known as secondary DNS server. In case primary DNS server are not available, secondary DNS server will provide this name resolution service. But the records are created, manipulated, modified only on the primary DNS server. The administrator can add, delete, modify the naming mapping in the primary DNS server only. So what does the secondary DNS server store? Secondary DNS server keep the copy of data present on the primary DNS server. जो भी primary DNS server पे record maintain होते हैं, उसकी replica secondary पे transfer हो जाती है. So this transfer between primary and secondary, multiple secondary servers are there, but there is only one primary server exists for a particular domain name or zone. So this primary to secondary DNS zone transfer happen over TCP 53 number port. Similarly, HTTP hypertext transfer protocol, a website is supposed to run on TCP 80 port by default. POP means post office protocol 110, NNTP network news transfer protocol 119, HTTPS means secure website which is supposed to be run on by default 443 TCP port. Then DNS 53 UDP, DHCP also run on UDP 67 and 68, TFTP 69, network time protocol run on port number 123 with the help of UDP protocol. Simple network management protocol run on port number 161 of UDP protocol. So if you want to allow block some services, suppose you want to block TFTP services in your organization. So you have to block the UDP with protocol number 69. You want to block incoming or outgoing. So you have to accordingly decide. If you want to block all outgoing requests to port number 69 from internal network to WAN network, then you have to block the outgoing request. If you want to block all the requests coming from 69 to internal network on any port, then accordingly you have to make rule. So depends on scenario, why you are going to block this port, what is the reason. So when you make any request to the target machine, for example, I'm just showing you the demonstration of a command. This command will be demonstrated in the module 3 also, network primer 3. So for the time being, I am just showing the command netstat. So this netstat -a will show you all the connection made between my laptop and remote machine. This remote machine can be my LAN machine, this machine can be WAN machine or any particular website. So by running this command, it will show lot of connections are established from my laptop to remote machine. So this output is showing that which protocol is being used for making this connection, what is the local address, what is the port number from local machine, what is the foreign address. Foreign address means remote machine. And what is the port number on the remote machine, and what is the state of this connection. So it is showing something like this. For example, it is showing that a TCP connection is established between this laptop IP address. This is my local IP address, and this is the port number 39,344 of my laptop. And this connection is made to some remote machine. It is not a complete name. It is a partial name is coming. And with the help of HTTPS connection, this connection has been established. Some data transfer is going inside this session. Some of the signal has sent. Some of them are in the closed wait state. So there are many types of states which will be covered in the next slide. Some of them are listening, waiting for request from remote machine. Means these services are running on this machine. Because already many connections are established, including the Cisco WebEx session. So many things is already happening in the background. So it is showing all this with the help of this command netstat -6. My computer is having additional IP address due to presence of many virtual and physical NIC card. So it is showing that the other NIC card is also making connection with this port to remote machine. Okay, so this is the local port on my laptop. This is the local port and this is the remote port. So basically this remote port is not appearing in the form of number. It is showing as a standard name, HTTPS. So there is one more option. If you want to see all this thing in numerical format, just type -n. Everything will be displayed in numerical format. HTTPS means 443.443. This is the remote port. This is the remote public IP address of remote machine. So all the public IP address are appearing here. And their connection state is also appearing: closed state, closed wait, established, sent. And some UDP related state is also, because UDP is stateless protocol. It will not show anything like established, listening. It will show something like this. And it is just showing that the data has been sent on the remote machine, but there is no connection state that established transferring data. It is just showing that recently this machine has sent some data to the remote machine. Now coming to slide. So basically it is showing that how the connections are initialized, from a local port to remote port, and how the response from remote port is received on the local port. For example, it is showing that host A want to make telnet to server Z. So it is sending some request like this: telnet request, destination port 23, source port 55,440. And this destination port is now responding destination port 5540 and source port, because this request is getting replied from 23. So this types of connection is established between TCP and UDP port. So now coming to network layer 3. After covering the application layer, presentation layer, session layer, transport layer, now we are in network layer, layer 3. So network layer is a provide logical topology, logical addressing, IP addressing, network addressing, or layer 3 addressing. You can say layer 3 addressing, or it is logical address, it is software addressing. IP address is software address, and MAC address is physical address or hardware address. So router device function at this layer, network layer, responsible for forwarding of packet. Now we are using the term packet. When we are talking about the network layer or router, we will always say packet. A router reads the packet. Router read the content of packet. Router forward a packet from one network to other network. A switch will read frame, switch forward frame from one port to other port. So switch make decision based on MAC address. Router make decision based on IP address or network address. And switch read the frame, router read IP packet. Inside the IP packet, what is the address? Source IP address, destination IP address. Inside the frame, what is the address? Source MAC address, destination MAC address. Inside the TCP or UDP, what is the address parameter? Source port number, destination port number. So network layer is responsible for routing, addressing of device, addressing of network, populating routing table, static routing, dynamic routing. All the forwarding decision for a packet, IP packet, is made on the basis of routing table. Internetworking between two different subnet, two different network, delivering packet to the destination with best effort, provide connection oriented and connection less mechanism. So network layer also have connection oriented, connection less mechanism. And layer 3 have two types of protocol. Two types of terminology: routed protocol, routing protocol. Routed protocol means the carrier protocol which is carrying the user data. For example, IP packet. IP packet is a routed protocol. And with the help of routing protocol, this routed protocol IP packet is being forwarded from one network to other network. So routed protocol can have IP, IPS, XPS, or Apple talk. So if we are focusing on TCP IP, we will talk about the IP packet only. Because IPX and Apple talk is related to some other networking software. So IP is a routed protocol which carry the user or application data, and this IP packet is forwarded to destination with the help of routing protocol or static routing. So routing protocol is a protocol that decides the route. So if we are trying to connect to Google website, our request is going in the form of IP packet, and this IP packet is passing through different routers on the internet backbone on the globe. Each router is having routing table. On the basis of content in the routing table, they are making decisions. Now this packet needs to be forwarded to Netherlands router, then it will be forwarded to Latin America. Then so there are many routes are there. And according to the routing protocol, dynamic routing protocol, this route will be decided. Or due to security reason, we can have a static routing table, which can be manually entered in the router, so that the particular packet will always follow the particular destination, particular route, due to security reason. But static routing is very complex. In case of large network, it is feasible in smaller network. So there are many types of dynamic routing protocol exist, like RIP protocol, IGRP, EIGRP, OSPF, border gateway protocol, BGP. So these are the routing protocol which is automatically deciding the automatic route for a destination. So these are the functions of network layer, layer 3. So router device, L3 device work at layer 3. And what is the address associated with network layer? IP address. For transport layer, port number. For data link layer, MAC address. For application layer, there can be different types of address depending on which application we are using. For example, domain name. So www.yahoo.com is the address related with application layer. Email address, our email address abhinav@xyz.com. So this address is basically application layer address. Now coming to data link layer. Data link layer is also known as layer 2. The switch device L2 switch work at layer 2 device. It defines the format of data. Finally, our original data, which is originating from application software, application layer. Suppose we are composing some mail. We want to visit some website. So this original data, which is visible to us, will be actually converting into frame. So this frame is finally handed over to our Ethernet card, our switch device, because they are the final machine who are involved in the processing of this data. So our original data is finally converting into a TCP segment or UDP datagram, depending on which applications are using this data. Then finally TCP or UDP will be converted into IP packet, then IP packet will be converted into frame. This frame will be finally converted into voltage, current, light wave or radio wave, depending on which media communication channels we are using. So data link layer is responsible for framing. The switching operation is carried out in data link layer. Whatever data is handed over from the network layer will be converted into frame. Then this frame will be converted to the data in accordance with the physical layer. The physical layer generally see the data in the form of 1010 binary number format. But this binary number are actually transmitted in the form of some wave or digital signal in the form of light or +5, -5, 0. This types of signal transmission is done. Some types of modulation, multiplexing. So everything is associated with physical layer. So this data link layer is very important because it is the final hardware device which is taking our data to the outside world from our machine. So there can be different types of protocol or standard exist at the data link layer like Ethernet. When we talk about the Ethernet is basically part of data link layer. Similarly, there are some other protocols are there like point-to-point protocol, frame relay. So these are the different terminology, data link layer technology. So data link layer defines hardware MAC address as well as communication process that occurs within a media cycle. Switches and bridge function at the data link layer. Error detection occur here, but not correction. So error can be detected by data link layer. Like switch can detect the error present in the frame or not, but it cannot be corrected. And they have two layers. Data link layer has two layers, sub-layer, logical link control layer and media access control layer. So the LLC layer is responsible for transferring the packet to the network layer, or it also identifies the address of network layer protocol from the header. It also provides flow control. Media access control layer is the link between logical link layer and network physical layer. It is used for transferring the packet over the network. Finally, data link layer is mainly used for framing, switching, MAC addressing, forwarding of frame from one port to another port, bridging table. All these are the part of data link layer. So data link layer have a function framing, physical addressing. Physical addressing means MAC address, hardware address or physical address. Flow control. So this address can vary. So if we are talking about the Ethernet based network, we will have MAC address. If we are using frame relay based technology, then they will have the equivalent physical address according to their structure. Flow control, error control, access control. So these are the functions of data link layer. Physical layer is the final layer in accordance with the ISO OSI model. It finally defines the physical property of our signal, its property of our connection, communication technology, connector type, cabling type. all the multiplexing technique, all types of modulation techniques are covered in this physical layer. And with respect to computer network, we can have a hub or repeater device at physical layer. But there are many devices exist at physical layer. If we talk about the different types of device, modulation device or transmitter device, so there can be transceiver device, transmitter. So all they can contribute to physical layer. So function is line configuration, pin out, what will be the voltage, what will be the signaling technique, half duplex, full duplex, topology, physical topology, signal transmission technology, light wave, current, voltage. So whatever thing is there, it is associated with the physical layer. So layer 1. So summarizing this ISO OSI upper layer, so there are 7 layers. So application, presentation and session layers contribute to upper layer of OSI. So simplifying this function, providing the user interface and presentation, present the data, handle processing such as encryption, decryption, compression. Session keep the different application data separate. Transport, provide reliable or unreliable delivery. Perform error correction before retransmit. Network, provide logical addressing, IP addressing, routing. Data link layer, combine packet into byte, byte into frame. Provide access to the media using MAC address. Perform error detection, not correction. Physical layer, move bit between devices with the help of voltage, wire specification, different types of cable, optical fiber, copper cable, radio frequency, satellite communication, uplink signal, downlink signal, everything is associated with physical layer. So finally, again summarizing this function, application layer can have file services, print services, messaging services, database services, application services. For example, email services, email protocol will exist at application layer because it is related to messaging. Presentation layer will have encryption, compression, translation services. Session will have dialog control. Transport will be responsible for end-to-end connection.
Voice is lost.
Yes, actually, I am just checking the WhatsApp, not WhatsApp, WebEx chat. Okay. So, transport network layer is responsible for routing. Data link layer is for framing, physical for physical topology. So this is the ending of OSI reference model, and this model is not actually exist practically. It is existing on paper. So you can refer to ISO OSI reference document on the OSI website, ISO website. And with respect to OSI model, each data corresponding to layer, each layer have some PDU terminology. For example, at application layer, presentation layer, or session layer, we generally treat the data unit as a data. The name can be given as data. This data is finally converted into TCP segment at transport layer, or if it is using UDP, then it will be converted into UDP datagram. Then this TCP segment or UDP datagram will be finally converted into IP packet. So packet is the terminology associated with network layer. And this packet is finally converted into frame, which is a part of data link layer. So whenever you are talking about the data link layer device, data link layer will be always interested in frame. They don't know about, they have no knowledge about the source IP address, destination IP address. So switch is not interested in IP address and destination IP address. Switch is only interested in MAC address. Similarly, router is only interested in IP packet for making decisions, IP address for making the decision. And at physical layer, we can use the PDU term, protocol data unit term, as a bit. So these are the terms used at different layers.